millions of queries are processed every single day. Chatbots are writing code, software is generating entire videos from simple text prompts, and data centers are running non-stop to keep up with the physical demand of artificial intelligence. But beneath the surface of programs built by OpenAI, Meta, and Google, there is a single hardware provider acting as the invisible landlord holding the entire system together. Today, that company is worth $2.7 trillion, boasting a valuation larger than the entire GDP of Russia. Yet this titan of modern computing was conceptualized over endless cups of coffee in an East San Jose Denny's booth. The sudden explosion of artificial intelligence feels completely spontaneous. In reality, it relies entirely on a specific hardware architecture that has existed for decades. To understand how one company trapped the entire tech industry in its ecosystem, we have to go back to 1993, when an obsession with making PC video games look better accidentally laid the groundwork for artificial superintelligence. When Jensen Huang, Chris Malachowski, and Curtis Preem decided to start NVIDIA, computers were strictly functional machines. They wanted to enable PCs to process complex 3D graphics so people could play video games at home. Their initial attempt to capture this market failed spectacularly. In 1995, they released the NV1 chip. They shipped 250,000 units to their retail partner, and 249,000 were sent right back. Following a canceled contract with Sega, the startup found itself with exactly 1 month of payroll left in the bank. The situation was so dire that "we're only 30 days away from going out of business" became the company's unofficial, desperate motto. With their backs against the wall, they built the Revo 128, selling 1 million units in 4 months and pulling the company back from the brink. By 1999, they followed up with the GeForce 256, the world's first programmable graphics processing unit, or GPU. Operating for years on the absolute edge of bankruptcy, permanently hardwired an extreme tolerance for risk into their corporate DNA. They were comfortable betting everything on a single vision. In 2006, NVIDIA released CUDA. This software platform allowed outside developers to program GPUs to perform complex, non-gaming calculations. Standard computer processors handle tasks in a linear sequence, one after another. But rendering detailed 3D video game environments requires calculating thousands of pixels simultaneously, demanding an architecture that can process massive amounts of parallel math at exactly the same time. University researchers testing the new CUDA software soon realized something unexpected. The mathematical process of training artificial neural networks requires this exact same parallel computing structure. This chart shows the massive performance gain researchers experienced when they swapped standard processors for GPUs. Teams at Stanford and Toronto saw processing speeds jump by 10 to 100 times, drastically reducing the time it took to train deep learning models. The ideal engine for artificial intelligence already existed. It had simply been engineered to make digital explosions look realistic on consumer gaming consoles. Despite these academic breakthroughs in the late 2000s, artificial intelligence had zero commercial viability. Nobody knew if it would ever be profitable. Jensen Huang saw the early research and chose to redirect thousands of engineers away from the highly lucrative gaming sector. He forced a wholesale pivot across the entire company to focus intensely on AI computing. They poured immense resources into developing the DGX, a massive, highly specialized supercomputer built specifically to train neural networks. To test the system's true capabilities, Huang personally hand-delivered the very first DGX unit to a small, relatively unknown research laboratory in San Francisco named OpenAI. They were building specialized equipment for a customer base that did not technically exist yet, supplying the precise tools necessary to construct an entirely new industry from scratch. When ChatGPT launched and crossed 100 million users in mere weeks, the resulting surge in demand created an immediate global panic among tech corporations desperate for processing power. Competitors rushed to catch up, but NVIDIA had already been optimizing for deep learning for over a decade. By late 2022, they held over 80% of the entire market share for dedicated GPUs. This total control translated directly to the balance sheet, with NVIDIA's data center revenue surging by 427% year-over-year as every major platform scrambled to rent their hardware. Their stock climbed by 2,000% over 5 years. A company that once begged for venture capital had surpassed the valuations of Meta, Amazon, and Apple. By intertwining their CUDA software platform with decades of specialized hardware advancements, they successfully forced the entire tech sector into total dependency on their ecosystem. Now, industry leaders publicly project that artificial intelligence systems will match or exceed human expert skill levels across most domains within a single decade. Anticipating this rapid acceleration, NVIDIA is placing high-stakes wagers, including a massive $50 million investment into the development of advanced humanoid robotics. Their position atop the global economy is the direct result of an accidental overlap between video game geometry and neural networks, aggressively weaponized by a leadership team completely unafraid of financial ruin. 3 engineers working out of a diner to make pixels move faster survived a string of near bankruptcies. Now they manufacture the exact physical infrastructure that will ultimately dictate the very next evolution of human capability.